So, take-home quiz number 1, very basic. I expect you to be able to find the mean and the median and the mode and the standard deviation. And while I'd like to say I'd like to be able to do it all algebraically, Joe, I'm going to take advantage of the technology that's there. So I'm not going to be all that fussy and say, you must be able to do this by hand. You must be able to do this by hand. Some stuff I will, this stuff I won't. So I'm going to go straight to my menu, stats, 4, 5, 7, 9, apparently were the scores. 6, 3, 8, 2, apparently were the frequencies. I want to do a calculation. I need to set the table. List, the frequencies were in list number 2. Exit, one variable calculation. Okay, so for 1 mark, the mean, did I say how many decimal places? No. I'm going to write 4.95. If you said 4.9, that's fine. I didn't say how many decimal places. So did I say 4? 5.95. Is it 5.95, right? The standard deviation is this one here, 1.67. Again, if you said 1.7, that's fine. 1 mark. You know what? The mode I can just find 7 because it appeared 8 times. The median 9, 10. I bet you, is the median 7 as well? Because there's 9 and 10. There's 19 objects, which means the median will be object number 10. There's 9 objects. The 10th object would appear in the group of 7s. And you can also get that from your calculator. I also expect you to be able to handle it when... I'm going to type this in list 3 just because. When there's only one of everything. So here's a list of data. 4, 8, 6, 9, 7, 5, 6, 4, 8, 9, 7, 4. I need to set the table. I type mine into list 3. How many of everything was there in this list? 1. How do I show that? Pick F1, frequency of 1. Exit. 1 there. Do you get a mean of 6.42? Standard deviation of 1.8. Oh. Twelve items apparently. Median 6.5. Wait a minute, Mr. Dueck, there isn't a 6.5 in the data. Well, there's 12 pieces. If you list them from smallest to biggest, the median would be halfway between item 6 and item 7, which is 6.5. The mode, can I just spot that? I think 4. Is it 4? Mode 4, and there's only 1 of them. 1 mark, 1 mark, 1 mark, 1. Yeah. Give yourself a score. Out of 8. Oh, Boston wants me to do this. He loves that joke. Give yourself a score out of 8. Pass them inwards, please. Hopefully nice 8 easy marks. If you would be so kind as to open your books to the homework from lesson 3, the standard deviation, which was page 228, well, 227. I am expecting that there are some questions, so I'll start out by saying any questions from the homework. And who does not have their workbook? You do absolutely need it today because we're going to be finally going to the inside cover pages. So if you don't have your workbook here, you want to sheepishly bring up some collateral of some type, and I will loan you one to follow along with. Questions from the homework. There were some tricky ones here, so I don't mind going over these. Oh, whoever was away last day, I checked lessons 1 and 2, so later on today, show them to me. Or those of you that didn't have it done, you're going to show it to me later on today. They went okay? Matt says they were all really easy. Then wow, I nailed a lesson for a change. Strangely, my math, I told you, this is, by the way, if you look at my Math 12 textbook, the workbook that we use, this is Principles of Math 12 stuff. Until 3 years ago, they removed it because the course was too full. And so I taught this to the honors, like Math 12. They found some of this stuff, so if you guys are finding this good, I'm impressed. What's that? I don't want it. Mark your own and hand it in. Yeah, hand it in. Back there, lock deep. So these all went okay. I said last day was one of the foundational lessons. Part 2 of it then is today. What we're going to try to do here, Joe, is this. If I know your Z score, what percent are you at compared to the rest of the population? I want to go from a Z-score, which we know how to calculate using this here thing. Where is it? This here. Where is this here thing? Can I then find out what percent you are on the normal curve? And the answer is I can. Lesson 4, please. Using Z-score tables, which is page 231. Okay. It says this. Recall the standard normal distribution curve as shown. Remember this thing? What's that there, Boston? The whole thing is the bell-shaped curve, but why? What's the zero? What's that? It begins with the letter M. That's the mean. Standard deviation is 1, and if we have a different mean and a different standard deviation, like we're measuring salmon length or whatever, we know how to convert into Z-scores using that equation from last day. Okay. So we're going to focus, Shania, on this one. And if we have data with a different mean, a different standard deviation, we'll just make them into Z-scores by going Z equals X minus mu all over standard deviation. That's going to be the calculator work that we're going to be doing more often than not. The numbers on the horizontal axis represented Z-scores and Z-score tables located on the last 2 pages of your workbook. Why don't you flip open the last 2 pages of your workbook? When you do that, you will see this. These are Z-score tables. Okay? They are all set up so that, remember that funky equation with the pi and the e, that really complicated one? Someone has graphed this using a graphing calculator and has calculated the areas, which, because the overall area is 1, means they're also percentages, to the left of every Z-score. If you have a pencil extra or a pen extra or a calculator case, you want to stick something in that back cover so that you can flip back there easily without always having to go hunting for it. Back to lesson 4. The way these tables work is they will give you the total area to the left of any Z-score that you know. So it's denoted by A of Z. The letter A stands for, Liam, area. Area to the left of Z, but nobody wants to write out area to the left of Z. So if I said, for example, you ready? Don't write this down, just watch. Find A of 2. I would go to my table. I would scan the Z-scores. Here's the negatives. Positives, 2.00. The area to the left of 2 is 0.9772. What if I said, Joe, find A of 1.63. So can you all look at your table at the back, please? This is how you read them. The first page has the negatives. 1.63, I would go like this. Here's 1.6, and then 1.63 would be that one right there. Okay? These are accurate to 2 decimal, sorry, the Z-scores are accurate to 2 decimal places, the tables are accurate to 4 decimal places. If you need to be more accurate than that, Jeremiah, you're doing research and you'd be actually using computers. 0.9484, that's the area to the left of 1.63. What if I wanted the area to the left of, let's erase this, Mr. Dueck. Well, let's go back to the lesson. Lesson 4. A negative Z-score tells you you're below the mean, shown to the left of the mean. A positive Z-score is above the mean. It's to the right. And a Z-score gives the, now because the total area is 1, what's 100% as a decimal? If I say give you 100%, what is that as a decimal? What's 50% as a decimal? Point what? 0.5. What's 100% as a decimal? 1. Because the area is 1, that means that any decimal I get, I can also convert to a percentage, which is nice if I want to like convert it to your provincial exam scores as a percentage. So the area, it gives the area under the curve to the left, or the percentage of data to the left, if you times it by 100, or the probability that a randomly chosen data value is to the left, because all probabilities are out of 100%. So now we're going to also, somewhere we'll work into here some kind of gambling odds and things like that. Oh, cool. So generally when they give me a Z-score question, Sydney, I will almost always do a quick little sketch. I've learned if I take the 1 second to do that, it gets rid of most of my mistakes, the dumb ones. It says, on the normal curve shown, shade the region where Z is less than to the left of -3, which we would also write area of -3. Boston, what number did you say this is?
0.
-3 would be over here somewhere. Draw that. And I would say we want this area here. I'll always quickly do a sketch like that, Marcus, because I've found it really clears things up for me to take the 1 second to do that. Now, B says, okay, find the area that's to the left of Z equals -3. So from the chart on in the back of your book, this is why I said, you know what I would do is I would either stick my calculator case back there or a spare pen. What I will do for Tuesday is I'll photocopy this onto one piece of paper so you can have a copy in front of you so you're not flipping back and forth. Jordan, I should have thought of that, but I may even do that later on in class. But for now, what was it, -3? -3.0, -3.9, 3.8, -3.0, oh, -3.00 is that. 0.0013. You see it, Simon? Area to the left of -3 is 0.0013. Which, Sam, I'd already actually told you because it's mentioned up here. See it? There's -3 and there's the 0.0013. But now I don't have to limit myself to 1 or -1 or 2 or -2 or 3 or -3. Now I can give you any standard deviation as decimals, any Z-score as decimals. Next page. Use the Z-score tables to calculate area to the left of -2. -2, remember this is 0. Aaron, -2 is about there. So I would do this and I would just color that in. I want that area there. From the table, now that we've turned the page, what is the area to the left of -2? So now that I've given you a Z-score, what is the Z-score to the left of, what is the area to the left of -2 from the table, please? Make sure you're on the negative side, which is, I think for you guys, the front side. 0.0228? Is that correct, people, or not? Yeah? So you have to move all the way over and drop down to 0? Okay. What's the area? Oh, +1. That would be right about there. So we're talking about this area here. From the Z-score table, what's the area to the left of +1? Joe, what's the area to the left of +1? Find +1, which I think is on the back page. Yes? And you want actually +1.00, right? Right? Good. 0.8413? Or 84%. It's not a coincidence that an A is 86, very close to 1 standard deviation above the mean. That's what. I don't know if you ever wondered, why 86%? It's slightly more than 1 standard deviation above the mean. 2 would be right about there. What's the area to the left of 2? Marcus? So let's talk about this in terms of heights. Let's suppose we measured Jordan's height and we found that he had a z-score of 2. So we found the mean of the average male population and we knew the standard deviation. We found that you had a z-score of 2. What that would tell us is that you're taller than 97.72% of the population. Or you'd be in the 97th percentile. Okay? Means you're above average, and you're even above average, but you're not Yao Ming like a freak. Yao Ming would probably be a z-score higher than 3. All right. So what kind of questions can I ask you? Well, stuff like this. Find the area under the curve for the standard normal distribution for each of the following z-score intervals. Z is, what does that symbol mean? Less than or greater than? Now, here's a dumb way to remember. This is my way. What capital letter is that from the alphabet? Does that look sort of like an L slanted? L for less than. That's greater than. That's less than, because it looks like an L. That's my dumb way, whatever works for you. Here's the whole point of that. Negative 2.15 is about there. And they want the area less than that. Now, the other way you can remember this is if you treat that like an arrow, Matt, which way is the arrow pointing? That way? What is a z-score to the left of negative 2.15? What percent of the population would be less than negative 2.15 if we had a big enough sample? 0.0158, is that right? Right, so so make sure you're on the negative, yes? Are you on the negative? No, it's not negative 2. So it's going to look up. Negative 2.15. Right there. Right? This gives you the second decimal place. The first decimal place comes from here. Is that okay? Yeah. There is, by the way, your graphing calculators do have these built in, and eventually I'll show you how to do that, but it's not as big a shortcut as the standard deviation thing. So I'm kind of 50-50. What would this be as a percentage? How do I go from a decimal to a percent? 1.58%. Okay. What would a z-score greater than to the right of? By the way, do you notice this arrow was pointing to the right? So here's my negative 2.15. How could I figure that out? Well, here's the problem. The charts only tell me that area, which we just figured out was that. How can I figure out this area? This is why I told you the total area underneath this curve. Do you guys remember what the total area underneath this curve was? 1. Yep. 1 minus 0.0158. What's the area to the right of negative 2.15? This is why I'm always going to do a sketch, by the way, to make sure I'm finding the right area. What is it? 0.9842 or 98.42%. This question said then convert each of the areas to a percentage, so okay. I'll follow the instructions. C. Z is between that and that. And that's how we'll write it. Because to write out, find the area between negative 2.15 and positive 2.15, way too much writing. We'll show it algebraically. Liam, hey, Z's between, that's the smaller one, that's the bigger one. The sketch. How can I find that? Now I'm going to have to do two calculations. The first thing I'm going to find is that area, which we already did in A. It was 0.0158, yes? Can you also now find me this area? Which is from your, find me the z-score of positive 2.15. What's that? Point? I didn't hear you. I'm sorry? 0.9798? Okay, right? Okay. So, by the way, useful trick, Matt? Ruler or a scrap piece of paper, lay it down. In other words, on my z-score table, I'll lay it down so that I can follow it down and cover up the other numbers and then just read straight across. Because you're right, it's lots to see. You see how we're finding it, though? Looks like this, kiddo. What are we finding? 2.15? So go to the positive. Yes? And then, Matt, look up, kiddo. Here's 2.1. 2.15, because this is the column with the 5, yes? Right there. Right? Well, it's tough to follow across. I learned when I was teaching this in Math 12, a couple of pieces of paper to kind of zig and zag, or a ruler, something to just help you follow it along a little bit easier is a huge help. What was it? 0.9842? So you ready? This is how we find an in-between. Sam, if this is 0.9842 and that's 0.0158, how can I figure out how big that area is? Subtract them. The bigger minus the smaller. In other words, the whole area, take away the tail, should be what's left. So on your calculator, Joe, what is 0.9842 minus 0.0158? Nope. .9842 minus 0.0158 is a point. Do you say that? Yep. Or 96.84%. Says determine to 4 decimal places the area under the curve for a standard normal distribution for each of the following z-score intervals. Okay. Z, that symbol there, less than to the left of or greater than to the right of. Again, if you're looking for a dumb way to remember, Joe, it's pointing to the left. Here's 2.08, about there. They want this area here. So this I can get straight from my table. What is the z-score area percentage associated with it, Sierra? Find from the table 2.08. .9812. Anybody else? Is that right? By the way, did they say in this one they wanted me to change it to a percentage, Boston? In the instructions? No, I'll leave it as decimal. What if I want to find all the areas of z-scores greater than, bigger than, to the right of 0.92? So 0.92 is right about there. By the way, you guys understand how I know where to sketch it? Because what's dead center? 0. So positive to the right, negative to the left. 0.92 about there. And they want these areas. I can't find those directly. My table will tell me that area. How will I find this area? 1 minus, can somebody find for me the area associated with, to the left of 0.92? Yeah, Marcus? Oh, I thought you had your hand up, sorry. let's see. So it's going to be 0.92, 0.8212, isn't that right? Right? Yep, 0.8212. .8212. What is 1 minus 0.8212? Point 0.1788. You okay with this, Alex? 1, 2, 3 more, and then I'm going to give you a bunch to practice before we move on to part 2. That we're between negative 1.75 and negative 1.02. So negative 1.75 about there. Negative 1.02 about there. We want that area. How? Joe, it's going to be this minus that. Will give me the... Okay. Negative 0.102. Negative 1.02. Negative 1.0. Negative, Mr. Dueck, careful. Negative 1. Don't have it on my screen. Negative 1.02. Is it 0.1539? Yeah. .1539, that's the bigger one, minus negative 1.75. Negative 1.75. Is it 0.0401? All right. What's the area between negative 1.75 and negative 1.02? Sorry? What's that as a percentage? What's that as a probability? It says if you were picking randomly, there's an 11.38% chance that you end up in there. So now we're also going to start eventually, hopefully, relating this a little bit to odds and probability. In fact, example 5 says, determine the following probabilities. Since probabilities are also percentages and out of 1, all it's really saying is find the z-score of game. We're going to call them probabilities. Between negative 1.83 and positive 2.65. So Liam, they want this area here. I'm going to have to do 2 calculations. Jordan, it's going to be that one, take away that one. Okay? What is 2.65? What's the z-score for 2.65? 0.9960 minus, what's the z-score for negative 1.83? Sam? Now, if you don't know how to, by the way, if you're not sure how we're reading the tables, this is your kind of chance to ask. Sorry? 0.0336, anybody else? Yeah? So Boston, what's the probability if we're picking at random that we end up between negative 1.83 and positive 2.65? Yeah. Takes 2 seconds. Or you can try doing it in your head. I'd probably just use the calculator. 0.9, I'm going to say 0.9624. Woo, I can do that in my head. There's a 96% chance that you end up in here. If you were making a bet, would you take that bet? Yeah, the odds are way in your favor. If you were making this bet, would you take that bet? Not without them saying, well, I'll give you 5-to-1 odds. So if you win, you'll get 5 times more money. Then I'd say 5 times that is over 50%. I don't know. Even so, I wouldn't take it. Last one. Find the probability that we're between 1.83 about there. And 2.65, which is over here. Find that area. Shania, how am I going to do that? This, take away that. 2.65 still 0.9960 because I have that on the last question. Okay, so it's going to be 0.9960 minus, now I just need 1.83, which I don't know. It's going to be somewhere probably in the 80s, I guess. 0.88 something. Alex, what's 1.83's area? 9664? 9664?
Yeah.
Can't be bigger. $1.83? Okay, well then our 2.65 has to be wrong. What did you guys tell me 2.6 was? Okay, what did you guys tell me this next one? What's 1.83? Sorry, 0.9?
1.9664.
Oh, I wrote this down wrong. Ha! No wonder I was confused. That's a 9, not a 6. I was going, how am I getting a smaller area to the left? That can't be right. Okay. What do you get when you go 0.9960 minus 0.9664? 0.0336? No, I'm wrong. Isn't it that? It's not. Oh, 0.0296. Good gosh, I'm way off, Jeremiah. Okay. So far, so good? Yeah? What's your homework? So take a look at this practice sheet, okay? See if you can find the following areas. Keeping in mind that if you're finding an area to the right, what's the total area underneath the curve? Sorry? 1. I'm not going to tell you that on a test. I figure it's fair game to ask you to remember the number 1. Okay. And then can you look at the back page, please? I think for all these ones, I would do, for number 25, a quick sketch. I would go, okay, there's the bell. There's 0. There's negative 0.85. And I'm finding this area. I would probably draw that really, really quickly to make it look like all the previous questions. Okay. I did an answer key. I did these in a rush. It's possible I might be wrong. Also, I was using software to do the answer key. You may find on the 3rd or 4th decimal place that you're off by 1. It's because the charts are less accurate than the software. I was cheating. I actually did this on the computer really, really quickly. So the mistakes are typos, not actual reading the chart mistakes. So that's part of your homework. Also, from the lesson, it says you can do questions 1, 2, and 3. So you can also do question 1, question 2, question 3. Yep. Any questions at all? We're good? Then yes, you may.